Hi, thanks for tuning in. My name is Ryan, and this is Intermediate Networking, IPSEC VPN. And just for fun, today's entry is the College Football Edition. First, a quick explanation of what an IPSEC VPN is. An IPSEC VPN encapsulates and encrypts data. It's like two people exchanging secret messages, and only these two people can decode what the other's writing. If anyone else were to get a hold of the message, it'd be unreadable because it's encrypted. Second, an IPSEC VPN can tunnel information across the internet. I can think of 1,000 pieces of personal information I wouldn't want the bad guys to get a hold of, like my address, my credit card number, or my medical bills. Last, IPSEC is not limited to the internet. We can also encrypt information internally. There may be a need to protect data from outside contractors or even sensitive financial data that not every employee needs to know. IPSEC's everywhere, and it's in every industry. It's safe, robust, and although today's demonstration uses Cisco equipment, it's standard across all vendor platforms. Yes, that means Check Point, Juniper, and any other IPSEC-enabled device will work with each other. And a few prerequisites. You need K9 iOS image. It means your router software has to support encryption. You ought to be able to find this out from wherever you download your image from on the Cisco support website. The actual file name will have the letter number K9 in it, and you should be able to know by that whether or not you have a K9. If you do a show version on your router, look at the bin file that's loaded and it should have K9. You also need standard IP connectivity. Now both nodes or routers need to be able to ping each other if they're going to be able to set up an IPSEC tunnel. And a couple prereqs not on the list. You need basic knowledge of router iOS. I'm just going to skip the basic stuff and really focus on just the IPSEC part. We don't have a lot of time, and I don't have time to go over every command option and every basic configuration. You also need a router with some muscle. I can't say off the top of my head how much resource overhead IPSEC will need. It varies depending on like the traffic and other factors, but you'll need more than what you're using now, that's for sure. Alright, on to the fun stuff. Here's our actual lab hardware setup. I've got two Cisco 1841 routers. Those are brand new, shipped with 12.4.3i image, and notice it's a K9 image, so it has what we need to do this IPSEC VPN. The two light blue cables are console cables connected to a COM port and a USB port on my PC, so we can program the routers. And that red cable is a crossover. I guess we could have used a switch, but just to keep it simple, we'll use a crossover cable for today's demo. Alright, and like I said, just for fun, today is the college football edition of this series. If you're wondering what's going on, if you're not from the States, it's basically American football and the college and university league, and we're using those locations for our two networks here. The #1 ranked team is from Norman, Oklahoma. Their network is simulated on loopback 0, 192.168.1.1 with a 24-bit mask. They're connected to what we'll call the internet. It's actually that crossover cable on fast Ethernet 00. IP address 10.1.1.1 with a 24-bit mask. Moving a short distance to Gainesville, Florida, home of the Gators. We're representing their network on loopback 0 at 192.168.2.1, 24-bit mask. And they're connected to the internet on fast Ether 00, 10.1.1.2 with a 24-bit mask. Alright, so we've been given a project to connect the two campuses of Norman, Oklahoma and Gainesville, Florida. They want the connection to be secure and encrypted. So we said we're going to configure a VPN, an IPSEC VPN between the two locations. And here are the steps we're going to take to accomplish this. First is an access list. If you've been doing this for a while, you'll notice that access lists have evolved into something more than just permitting and denying traffic and IPs from each other. They've actually evolved into something that we use to define traffic and later decide what to do with traffic that matches that access list. Secondly is an ISACAMP policy. Not sure if that's how that's supposed to be pronounced, but that's how I'm going to say it for the rest of this video. This ISACAMP policy will define below the pre-shared key and how that's encrypted. Moving down is the IPSEC transform set. This is a set of algorithms that we're going to use to apply to packets. And below that, to actually apply those to packets, you need to create a crypto map. And lastly, we need to apply that crypto map to an interface, just like with QoS or other types of Cisco configurations. This map needs to be applied to an interface for it to actually be effective.